In this video, I'd like to talk about the concept of inverse functions, or essentially these are functions that reverse each other. So let's say if we have some function where the domain of our function are the x values 1, 2, and 3, and we know that this function maps each of these values to different y values. So these are our x values and these are our y values. And we're going to have a function that basically takes each of these x values to a specific y value. So let's say the point 1 goes to a y value of 6, the point 2 goes to a y value of 9, and the point 3 goes to a y value of 12. So this is what functions do. They take some kind of input, an x value, and they give you an output, some y value. Now an inverse function essentially switches this. So for an inverse function, which we usually write with an f with a little -1 next to it, it essentially gives you the y value and says what is the x value. So an inverse function would map the y value of 12 to an x value of 3, a y value of 9 to a y value of 2, and a y value of 6 to a y value of 1. So inverse functions essentially switch the x and y values. And we'll see this in greater detail later. But basically with an inverse function, it's giving you the y value and asking what is the x value. Whereas in a normal function, let's say f of x is 2x plus 1, when I put f of 1 in here, this is given an x value of 1, what is the y value? And in this case, the y value would be 3. But the inverse function could look like this. The inverse of 3, this is given a y value of 3 with this function, what is the x value that gets this y value? And this answer would be 1. Since to get a y value of 3, you need an x value of 1. So let's take a look at a few more examples just so that you can get a better idea of what this concept actually represents. And here you can see we have this graph, y is equal to g of x. And for normal function notation, if I ask the question, what is g of 2? So this is given an x value of 2, what is the y value? So I find an x value of 2, and I go up to its y value. It looks like g of 2 would just be 2. Now I could ask the question, what is g inverse of, let's say, -4? So this is given a y value of -4, what is the x value? So I go and I find a y value of -4, which is essentially anything along this line here, and it intersects here, and it looks like that's an x value of maybe like 0.7. And I could also ask, let's say, what is g inverse of 6? So again, this is given a y value of 6, what is the x value? So I go up to a y value of 6, I go over to my function right here, and that looks like an x value of 2.5. So in summary, when given something using this notation, the inverse notation, this number on the inside is the y value, and essentially what is the x value is what this question is asking. So given a y value of 6, which x value gives you that? And we found that x would have to be 2.5 to give a y value of 6. And notice it's essentially the reverse if I just asked what is g of 2.5. So this is given an x value of 2.5, what is the y value? So I find an x value 2.5, I go up to the graph, and again, that's just 6. So notice how the regular function notation and the inverse function notation, the x and the y values are switched.